What I don't understand is why if x plus y equals the same as the k on the bottom of that one.
Hold on.
Why
So
would
what?
it just
Because
cross
what I'm
off now?
thinking is it's not going to cross out so easy.
Because it's bigger.
Mm-hmm.
Like you mean in our previous step where we just crossed out y's?
Do you get what I'm saying?
No.
Because normally the reason you cross stuff out is because as you go through the process, things dissociate less. Like the first time it happens, it'll dissociate maybe like 40% of it, but then you get only 40% of the original concentration to your next step. So that's just going to dissociate, and it's not even going to dissociate at as high of a rate. So then you get like way less, and then by the last time, so that's why you start like -3. So you dissociate some, less. Your K is getting smaller. So when your K gets smaller, you're dissociating less.
So this one's dissociating more?
More, apparently, from what you get.
Huh.
And so then you would have to actually like.
Too quadratic.
Looks like you'd actually have to solve everything.
What? It's stupid. I don't want to do it. Wouldn't our first two steps be the same though? Because we still figured out that the first step, it was less than 5%.
So our first step's fine.
And then our second step would be the same because we're canceling out those two.
Then our
And-
second step.
You know, because we have those two on top of each other. So
I'm
we
pretty sure
cancel
the
out.
second step's going to be this.
Yeah.
But then
So
the
then our
third
third
step,
step-
though.
But I don't get it because our x plus y is the same as our bottom thing. So like it should just cancel all of it out and z should equal our k3 value. Do you know what I mean?
So wait, hold on. Our x plus y.
Of hydronium.
Yeah.
It should just cancel out and z should equal 3.2 times 10 to the negative 2.
Wait.
Right?
How could you cancel it out?
Well, because you have the same number plus c over 1.1 times 10 to the negative 7 minus c.
Yeah, but you can't cancel with subtraction like that.
How do we cancel that one then?
This one, when you.
It's like the same exact thing but different numbers.
So this is irrelevant, right? And then so now does he give you answers for it or anything?
No.
No?
But I'm just gonna go ask him tomorrow if that's correct.
Okay. So let's look. You have so you do the first one. Do the 5% rule, which worked.
Yeah. And this one is the same exact thing. Our y is the same as our k2 value given. It's given there.
That's how he does it.
Yeah.
See, I remember that. That worked. Oh, because here.
Where did you get the x?
So we did x times y. Oh,
Wait, what? Why does he have all three exponents on everything?
So here, though, so we have x. These ones we're not dealing with yet. For this.
Y and Z, you mean?
Mm-hmm.
So that's why he crosses them out.
Oh, well, I guess the reason he has them here is because it's like the hydronium. Your total hydronium is this.
X plus Y plus Z.
Mm-hmm.
That makes sense.
But he's saying Y and Z don't matter.
Mm-hmm.
So he's saying it's basically x times x.
Okay.
So you get x times x over 5. So that's what we did.
Yeah.
Then here, he did the same thing. So x times y over x. Hold on.
Then you did this.
See, but
X.
this is where, so this is a normal one.
Yeah.
Like going from dissociates.
Smaller.
Yeah, and the k is getting smaller. So let's just do this real quick. So that's why you go to here and you say x, this x. So like here, he said this y is small compared to that when the dissociation is getting smaller. So that goes away basically. So you have y times x. This goes away.
Okay. So cancel those out.
Yeah.
Okay.
Okay, so that's how that one worked.
Okay.
So now the reason I'm like confused is because he's doing it backwards, but we'll worry about that after in a second. So then you go to the last one. So that's why I said, so if you have that pattern, the normal pattern,
Mm-hmm.
K2 equals Y,
Yeah.
because that happened.
Okay.
So then you get to the last one, and what you're gonna do is say, the Z doesn't matter. Well, what he does here. Set x times Z over Y. So we get x times Z over Y. So here's our Y, right?
Yeah. And that's our X, 7.6 times 10 to the negative 16.
Mm-hmm. And then he says you have x plus y times z. So you're gonna go, and this z is normal here, but we don't care about it. And then here, we don't care about this z. So this, so you get x times y. X times y over z. Is that what we're doing?
Yeah. X times Z.
X times z over y. What is that? X times. Oh. Because this doesn't matter. So basically it's
Because
just
it doesn't
x.
matter down there.
Because it's so small compared to this.
Okay.
So when you plug in this number, even when you add them together, it's basically x.
Yeah, but X is smaller than Y. Our X value is smaller
For
than
this
the Y
one.
value. Yeah.
But not in the normal one,
Okay.
right?
Yeah.
So in a normal one, the x is going to be a lot bigger than the y.
Okay.
So then he just puts x. So then you just get x plus z times z. But then this z is small, so it goes away. So you have z times x over y. And then you'd have to solve it. So you just plug in your x, which
And
we
your
solved
y.
earlier. And the y, right?
Yeah, so it'd be seven.
So then
it'd
you
be
solve
Z
z.
times 7.6 times 10 to the negative 16 over 1.1 times 10 to the negative 7.
Equals this. Then you do it all out, and you get your z. So then you get your concentration of this, right?
Yeah.
So now the thing though is he's doing it backwards.
Okay.
So these changes all of a sudden become relevant. So let's try to do it like that. You ready for this?
Do it backwards.
Reset.
Do it regular way.
So that's the regular way, the way that makes more sense. How we're
Okay.
thinking, right? So you go about it and look like we're getting so much. The k is getting so much smaller.
Yeah,
these new things that we're making, so like y compared to x
yeah.
is nothing. So we don't even worry about the y kind of stuff.
That stuff always bothers me because I never know when to like get rid of it. Because I know it's like, know when it's small, but it's kind of just like,
So when you look at it, it's because, think about, here let's just look at this. 7.5 times 10 to the negative third. That k is referring to how this is dissociating, kind of idea.
yeah.
Okay, so it dissociates into something.
Yeah.
So let's say we went from like 0.5 to 0.05. We made that much over here.
But in this one, it's getting smaller. So
Yeah, this
it's-
one's different, but I'm just saying
in general. it
So let's
goes-
say we go to here, right?
Yeah.
So we get 0.05, and then this 0.05 is going to dissociate, but it's even smaller, the rate at which it dissociates.
Mhm.
So it'll make like 0.005. And so do you see, like, as we go, it's even going to be smaller than that.
Yeah, because it's
But-
associated.
Yeah, so as we go, let's say it's like that. This to this is
Uh-huh.
irrelevant. I mean, these are relevant, so let's do something like this. Okay,
Yeah.
so this doesn't affect this. This doesn't affect this.
Yeah.
So that's why he starts going like, well, if we're dealing with these two together, we don't care about this. So we're just gonna look at this number.
Okay.
If we're dealing with these two, all three of these together,
We
we don't care about
either.
either of these. We're just gonna look at this.
Okay.
So that's when he starts just like throwing stuff out.
Okay.
Because, you know, like in your calculator when you put it in, you said it's basically 0.1 still.
Yeah.
Because this number was so small,
It didn't affect
it didn't even affect it. What did it become, like 0.0999?
Yeah.
Right.
Yeah.
And so when we look at it, if we take this and subtract 0.05, or take 0.1 minus 0.05,
Mhm.
it's gonna be practically
Yeah.
the same thing. So that's why we're like, well, we don't care to make it into this. We'll just ignore y. That dissociation.
That makes sense.
So that's why they start doing that, just to get rid of numbers, because you don't want to have to be dealing with like
Yeah.
0.1 and then 0.099999 and then
Yeah, 'cause it's the same
0.099997.
thing.
Yeah.
Okay. That makes sense.